What's up, everyone? In this video, we're going to be going over some compositions of transformations. Now, in this lesson, we're going to just be working with all of the transformations together. So composition just means that we're going to be doing multiple transformations on the same pre-image. So far we've done a lot. We've done translations, which are of the form t x comma y, right, where those x and y values are how much we're manipulating our x and y coordinates. We've also done reflections, where reflections are the lowercase r, and then we have our line of reflection, usually y equals something, or we have reflection x equals something. And with reflections, again, we're thinking about that mirror image that we're creating. We've also done rotations, which is the capital R, and then we have an angle as a subscript there. And then last but not least, we have our dilations, which are of the form with the capital D, and then we have whatever, there's going to be a value here, or scale factor, written as a subscript there. So in this lesson, we're going to be dealing with all of these in a bunch of different combinations, but what you need to know is that we read compositions backwards. So you might see something like this written, and instead of your typical reading left to right, you have to read from right to left. So you read backwards. Now, what this means is if this was given to us as a question, we are rotating our figure by 90 degrees first. That is what we see all the way to the right. Then we are doing that translation second. So this comes first, this comes second. And then last but not least, we have the reflection over the line y equals x. That would be the last thing that we do. So let's just get right into an example here. So it says, given the point A, -2, 3, state the coordinates of the image of A under this composition here. So remember, we read right to left. So I know that I am first doing a reflection over the x-axis. Now, there are two possible ways you can do this. If you remember the rule, you know that when you reflect over the x-axis, the y-coordinate is negated. Or you can just do the reflection, create the mirror image. So we highlight our line of reflection, we count our distance. Since this is perfectly horizontal, we can just count the distance down. So we have 1, 2, we are 3 units away. So we need to go 3 units away to find A prime. So A prime, no matter what method we use, A prime is going to be at -2, -3. Now remember, the word negated means we're just changing the sign of it. So if this was actually a negative number, to negate it, you just change the sign to make it positive. So now for A double prime, we are taking this point that we just found here, we're taking -2, -3, and then we're performing the translation on that. We are not going back to this original point A and then completing that translation. We are doing the reflection first, and then the results of our reflection, we are using that in our translation. So now we are taking A prime, which is at -2, -3, and we are completing this translation rule on it. Now, what this translation rule is saying is that we are going to be subtracting 3 from our x-coordinate. So let's do that first. We subtract 3 from our x-coordinate, and then we're going to be subtracting 4 from our y-coordinate. Or in other words, if you want to read this in another way, we're going to be moving the point to the left 3 and down 4. So it's good to know both ways, because if you have a graph, you could just move your point to the left 3, down 4, and get your coordinate. If you didn't have a graph, you can mathematically do it. So -2 minus 3 is -5. And then we have -3 minus 4 is -7. So the point should be at -5, -7. Now let's just double check this. If we move to the left 3 and down 1, 2, 3, 4, our point A double prime now would be here, which is at -5, -7. Now, notice we've done 2 transformations, so we are calling the point A double prime. So usually that's an indicator. If you see like 2 prime symbols or 3 prime symbols, that usually means that we are doing 2 or 3 or however many marks there are. That's how many transformations we will do. Now, it doesn't always have to have a prime symbol, but sometimes if that's there, it can kind of give you a hint as to how many you need to do. Now, these are some helpful tips because the second part of this lesson is you're going to be, so in this question, we were given a point of a pre-image, and now you might be given a point or multiple points if it's a triangle or a quadrilateral, and we're performing these different transformations on those points. But the other types of questions that we're going to be given are, you guys are going to be given pictures of pre-images and images, and it's going to say, hey, what sequence of transformations will map one figure onto the other? So we have to figure out, like, hey, how do I know, or what's a dead giveaway that we have a translation? Or what's a dead giveaway that there's a reflection? What's a dead giveaway that there's a rotation? And what's a dead giveaway that there's a dilation? We're going to have to get pretty quick with being able to just identify or at least like eliminate some choices. So what we're actually going to have to do with those types of questions is it's going to be really helpful if we can just take a look at the diagram and like identify what transformations we know are going to be present, and then we can figure out the nitty-gritty later. So a translation, you're going to have the same exact orientation of points, which means your figures are going to look exactly the same, but they're going to be in a different spot. Now, reflection is pretty important because we're talking about a flipped image, right? That mirror image results in it being flipped. So if we take a look at an example, and I want you guys to draw this in as well, if we have a figure like this, and it is reflected over this dashed line right here. When we actually draw our points in, it's going to look something like this, right? Now, naming the pre-image and the image, right? This is our pre-image and this is our image. Naming the pre-image and image are going to really help with this because this is the only figure or the only transformation where this is going to happen. So if we pick a point on our pre-image and we decide to name it clockwise, we can name this figure triangle ABC, right? Now we started with A, so let's start with A prime here. Let's pick that point and let's also go clockwise. If we name this figure, we get A prime, C prime, B prime, right? So if you take a look at the order, this goes ABC and this goes ACB. So when the order of those points change, if the names are different, you know that's a dead giveaway that there's a reflection there. So with a rotation, the orientation of our figures is different. Like they're going to not look exactly the same, but the name should be the same. So if we have a triangle like this and we name this triangle ABC, and then we rotate that triangle around, maybe to look something like this, we can kind of clearly see that the orientation isn't the same. But if we name our pre-image over here, if we pick a point A here and we go clockwise, we can name this figure triangle ABC. Now if we pick A prime over here and we go clockwise again, we get triangle A prime, B prime, C prime, right? So you can see the order of the vertices is staying the same. So that's kind of another giveaway, right? If the orientation looks different but the names are the same, you know that you have a rotation. And a dilation I feel like is the easiest one because if the size of your figures is different, you know a dilation is involved. It's just a matter of, hey, what's my scale factor and what is my center, right? So just make sure you guys are looking for that. If the names of the figures are the same, you know that it can't be a reflection. And I feel like a reflection and rotation might be the hardest ones to identify. So make sure you use this table to help. So let's do some examples. So it says, what is the sequence of transformations that can map triangle ABC onto triangle A double prime, B double prime, C double prime? Is ABC congruent to A double prime, B double prime, C double prime? Explain in terms of rigid motion. So let's do some tests here. So the first thing I'm going to test just the names of the figures. Because, like, to me, by a quick glance, I can see that this figure is, like, translated around. But let's just double check. So I know this is my pre-image here because there's no prime marks. And I know this is my image here. So I like to label those. And I'm going to start at A. And I'm just going to go ahead and label here. Or I'm going to go ahead and name it. So to name this triangle ABC, I would actually have to go counterclockwise here. So to name, we triangle ABC. So let's start at A double prime here, and I'm going to go the same direction. So if I go counterclockwise, the name that I get here would be A double prime, C double prime, B double prime. So right now, the names here are not matching up. The letters are not matching up, so I know a reflection must be involved. Now, even if you didn't do this, if you didn't mark this all up, you can kind of take a look at the points, right? Like, C ends up being really close to the y-axis over here, right? And then it's also close to the, like, I can kind of see that that mirror image is created. It's not a perfect mirror image yet. Maybe we have to move the figure around a little bit. But to me, it looks like a sort of mirror image is being created. So I think what I want to do here, and there can be so many correct answers, as long as your answer makes sense, though, it doesn't really matter. So I think the first thing that I want to do, because my end goal, I'm going to have a reflection over the y-axis. I think that's what I want to go for. So I know I want to have this in there somehow, but I need to do something first. It's not a reflection over the y-axis yet. I'm gonna try to move my points around. So I can see if I take point C and I bring it down a little bit, then it looks to me like that would be a perfect mirror image. Like if C prime was here and we do that reflection over the y-axis, it would map on to C double prime. So the first thing that we need to do here is let's take triangle ABC and let's translate it. So we want to translate it 2 units down, which means we're going to subtract 2 from our y value. So I think the first thing we want to do, we don't have to change the x-coordinates. We don't need to move these points left or right at all. So let's not change the x-coordinate, but let's subtract 2 from the y value. So if we did that, A prime would be here, B prime would be here, A prime would be here, and C prime would be right there. And it helps to like sketch this out too. Now, after we've done this, let's test if we reflect it over the y-axis, if it would actually map onto A double prime. So A prime is 4 units away, and A double prime is also 4 units away. That's a mirror image. We already tested C prime out. And then B prime is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it actually matches up perfectly. So now it's a matter of I am reflecting over the y-axis and I'm doing this translation, but what do I need to do first? Well, we're doing there are 2 different ways that you can write this out. So you can write it out in words. You can say, hey, translate triangle ABC down 2 units, and then reflect it over the y-axis. That's one way, in words. You can verbally say that. Or you can use the notation of the composition of transformation. So writing the words might take you a little bit longer, and I know you guys look for shortcuts all the time, so again, we're translating first, right? So that should be, we got to read backwards. So we're translating first, and then we're doing a reflection over the y-axis. So either of these answers here would suffice for saying the sequence of transformations, but the second part says, explain in terms of rigid motions why these are congruent. So in this case, we have to add on to our explanation. So I'll do that part in a different color. So let's do this in blue. So triangle ABC is congruent to triangle A double prime, B double prime, C double prime, because now we have to explain. A translation and a reflection are both rigid motions. So side lengths and angle measures are preserved. And that is a perfect explanation. So you want to make sure, I would always over-explain instead of under-explaining. And if it's saying explain in terms of rigid motions, you need to mention those words, rigid motions. And you can see we did that, right? Rigid motions are here. Now, after you talk about rigid motions, you always should mention, hey, we're preserving side lengths and angle measures, and you can guarantee your points like that. So for this question, I want you guys to try to do this on your own. And again, the first thing I would test is eliminate some. You can see that this is not a dilation. You know this isn't a dilation right away because it tells you that the pentagons are congruent. So we know that this is not a dilation. And what you guys should also do is test the names, right? If you start at A and you go clockwise, the name of this is A, B, C, D, E. If you start at A double prime and you go clockwise, we get A, B, C, D, E. The names are the same, so I also know there's no reflection, right? There's no flipping of the image. Now, to me, there's definitely a rotation here. You have to rotate this figure to get it into this orientation, but it's a matter of how much are you rotating, what is your center of rotation, and then you might also have to translate it. You might not have to translate it. So, and again, there are a lot of different answers here. So if you want to test rotating it about a point, maybe rotating about point A, or test rotating it about the origin, test it, plot it, and then see what you got, and then we'll talk about this more when we come into class.